want to shoot some hoops? No, you don't have to be like that. Come on and play. Look, he likes you. Don't you have time for a little one-on-one? How long has it been since you played? Come on, you got the ball. Take a shot. No, my lady, not from there. It's out of bounds. Gotta be on the court to be in play. Welcome to Duke Reginald's court of unending possibilities. Gotta sink the last one.
That hurt.
It never touched you.
Right.
And it's not solid. Its ball is mostly empty.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale, in the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty.
Most people think that the vacuum is empty. But for internal consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
Organizations like NASA, British Aerospace, are all trying to tap into this incredible, unimaginably large energy sea. And they feel if they can tap this, we can travel to different galaxies. So they understand that in empty space, there is this unbelievable energy.
When you begin to really grasp this, you begin to grasp the enormity of the energy that would be involved in going down this rabbit hole. What is available for us to use in the future to take us to the stars? The issue is we are perturbing this with consciousness. We are able to, with directed consciousness and intention, we are changing things at the vacuum level, which then allow us to access a new level of physics. So we can do that at that level, not so much at the atom molecule level. That's a secondary effect. So we're already doing it, in essence. We're already getting into the rabbit hole by using intention.
We're really living in a thought universe, a conceptual universe. Quantum mechanics is just the play and display of potentiality.
If you put it that there is an intangible world that affects the tangible world of our experience, and if you then say that's what quantum mechanics says, and granted, that's a fair way of trying to put into English something which is very, very difficult to grasp, but it then leads quite naturally to the conclusion that quantum mechanics says that there is a spiritual world that makes this choice, that there's another world that is intangible, that affects and influences the physical world. And really, while that statement might be true, quantum mechanics absolutely does not say that. That intangibility, however, is itself the bedrock of physical reality. It may be intangible, but it is, and we can't really say what it is or why it's there, but it is in fact the most fundamental feature of matter. So you could say, well, if it's a feature of matter, that's not intangible. Matter is the most tangible of things. So, I mean, these are word games. The fact of the matter is that the matter is not what we have long thought it to be. To the scientist, matter has always been thought of as sort of the ultimate in that which is static and predictable. And the more you understand the material aspect of something, the more perfectly predictable it is. What quantum mechanics illustrates is that that is simply not true.
The major basic idea that quantum physics implies, which makes us understand this or even think about this new paradigm, the thing which is that there's this underground, there's got to be a realm of existence which cannot be ever touched on or seen, which bubbles into the existence giving rise to our understanding of the world.
The tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life? At the basis of it all, life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, pure abstract being, pure abstract self-aware consciousness, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
What makes up things are not more things, but what makes up things are ideas, concepts, information.